Today we see estimation of dissolved oxygen in given water sample by Wrinkled method. For that estimation we first see principle of Wrinkled method. Manganese sulfate reacts with KOH to form with PPT to a manganese hydroxide in presence of oxygen. Manganese hydroxide get oxidized to brown color compound in strong acid medium. Manganese ions are reduced by iodide ions which get converted into iodide ions equivalent to original concentration of oxygen in water. The iodide can the iodine can ti- titrate against sodium thiosulfate, that is NaSO3, using starch as an indicator. Here we see the reactions of Wrinkler method, that is iodometric method. Here we see manganese sulfate is reacts with KOH and which form the brown color which form the PPT of manganese hydroxide, and in presence of O2 manganese hydroxide get oxidized to form a brown color compound, that is MnSO4, twice MnSO4. Then manganese ions are reduced by iodide ions and which get converted into iodide ions equivalent to original concentration of oxygen in water. And lastly, the iodide ions can be titrated against the sodium thiosulfate by using an starch as an indicator. Now for that estimation we see the reagents. How to prepare reagents? Sodium thiosulfate, that is 0.025 normal solution we taken. Then firstly we see how to make sodium thiosulfate. Dissolve 6.205 gram of sodium thiosulfate in boiled distilled water and make the final volume up to the 1 liter and add small amount of NaOH as an stabilizer. Then next reagent is that alkaline potassium iodide solution, that is Ki solution. Dissolve 25 gram of KOH and 12.5 gram of Ki in 50 ml of boiled distilled water. In this way we prepare the alkaline potassium iodide solution. Then manganese sulfate solution. Dissolve 25 gram of MnSO4 into 50 ml of boiled distilled water. Then formation of starch solution. Dissolve 500 milligram of starch in 50 ml of warm water and add a drop of formaldehyde solution. And then also for reagent use concentrated sulfuric acid. These are the reagents which are used for the estimation. Now we see the procedure for this practical. Firstly, fill up the water sample in stopper bottle. Gently fill that water in such a way that the atmospheric oxygen does not dissolve in such sample. Then next add 1 ml of alkaline phosphate iodide, that is Pi3, with the help of pipette. After that add 1 ml of manganese solution with the help of pipette. Afterwards place the stopper and shake the content by inverting the bottle. Then add 1 ml of concentrated sulfuric acid by pipette and wait for 10 minutes for the settlement of the PPT. Then Take a 50 ml of sample from it and put it in a conical flask and add starch solution as an indicator, and this above solution above whole solution titrate with sodium thiosulfate, which are filled in your burette. This picture showing the formation of sample. For this practical, we see the observations. Burette which is filled with 0.025 normal sodium thiosulfate, then pipette containing 50 ml of sample, then indicator starch solution acting as an indicator, and end point is that dark brown to blue to colorless is the end point of this practice. After titration, we see the observation table. In observation table, make a table containing score number, burette reading in ml, and mean burette reading. You have to take 3 burette reading. In picture, we see that there is 3 burette reading, burette first, second, and third. Here, this picture showing 3 readings which are performed by the students. The first reading is 1.9 ml. By titrating the sample with sodium thiosulfate, uh, we taken a reading that is 1.9 ml, second is 2.0, and third is 2.1 ml. So mean burette reading is 2. Now we see the calculation part of this practical. For the calculation, there is again formula. So dissolve for the dissolved oxygen is calculated in milligram per liter. So for dissolved oxygen is equal to MBR, means mean burette reading, into capital N into capital B into 100 upon V. So N, capital N, is equal to normality of sodium thiosulfate, that is 0.025 normal. MBR means mean burette reading. Capital B is equal to equivalent weight of oxygen, that is 8. V is the volume of sample, that is 50 ml we taken. Then so for dissolved O2, MBR into capital N into B into 100 upon 50. So here MBR is 2, capital N is 0.025 into 8 into B is the 8, and into 100 upon 50. So we have value 40 divided by 50. So for dissolved O2 we have value 0.8 milligram per liter. So from this reading we calculated, or we conclude our result, that is the dissolved oxygen of given water sample is containing 0.8 milligram per liter. This is the calculation for this practical, and this is a result. Thank you.